One of the main important things about chemistry and whether or not we know a chemical reaction has taken place is the energy of that reaction. And so what I want to talk about now is what is energy. Energy is one of those things that we use in everyday language and in our conversations, but you don't probably know exactly what energy is. And in fact, most people don't know what energy is. That's something that we're still trying to really figure out and try to characterize. Chemistry and all of science, for that matter, is all about trying to figure out the world around us and try to nail down exactly what everything really is and give a really good definition about things. And so what I'm going to talk to you now is basically things dealing with energy, and we're going to go over a bunch of terms and definitions of those terms that all relate to energy. So first, what is energy? Well, energy is the ability to do work or to produce heat. And so, for example, you might think, all right, I have lots and lots of energy, or I have no energy because you've been up all night. Well, when you feel that way, that you have no energy or you have lots of energy, that basically means that you're hyper and you're ready to get going, or you just kind of want to sleep and just do nothing. So it's your ability to do work, which is in essence to do things. In science, work has a very specific definition, which I'm not going to get into, but I would recommend that you kind of go and delve deeper into that. But energy is simply the ability to do the work or to produce heat. So some energy is able to produce heat. And heat is simply the energy or the flow of energy from one object to another. That's how we define heat. Now, one of the probably most important things in all of science is the law of conservation of energy. Now, if you've done balancing equations and things like that, you've already experienced the law of conservation of mass. Well, law of conservation of energy is equivalent to the law of conservation of mass. Law of conservation of energy simply says we cannot create or destroy energy. Energy is constant in the universe. Energy can't be created and it can't be destroyed. So you might say, well, what about, I don't know, when we're building things and designing machines or things like that, and we end up using all that energy, and so energy just gets used up and disappears. But energy really doesn't disappear. What ends up happening is that the energy gets transferred or transformed from one form to another. Now, we're going to go over the different types of energy or different forms of energy that there are. But before we do that, let's first talk a little bit about the common types of energy. And there's really just two types of energy that kind of encompasses lots of different things. And that is kinetic energy and potential energy. Kinetic energy is simply the energy of motion. If something is moving, it has kinetic energy. So remember, energy is the ability to do work. Something is moving, think about a bowling ball moving down a bowling lane. As that bowling ball is moving, it has a potential of knocking down all the pins. Now again, it may not do that. For example, when I go bowling, it usually just goes straight into the gutter. But for something to move, that means work has been done on that object. And so that bowling ball going down the lane will end up impacting the bowling pins, causing them to move and doing work on them. And so that work, or I should say that energy, is kinetic energy. That bowling ball is moving, so therefore it has lots of kinetic energy. And things that move faster have greater kinetic energy. Also, things that are more massive have more kinetic energy. Now, the other type of energy, or common type of energy, is potential energy. Potential energy is just simply the potential, for lack of a better word, or the ability to actually do things. And so, or in this case, the ability to do work. Now, the most common type of potential energy is gravitational potential energy. And so what that basically means is that an object has the ability to do work, has energy based on its position, its vertical position in a gravitational field. Here on Earth, that gravitational field is the Earth itself. If an object is really high off the ground, it has a lot more potential to do work than if it was lower or closer to the ground. And so gravitational potential energy is the energy that an object has based on its relative distance to some reference point, which is usually the ground. Now, a good example of how energy can get converted from one form to another is a pendulum. Now, a pendulum is something that swings on a string. And so if we can imagine, let me get a pendulum. So here's a pendulum that I've found, and all a pendulum is some weight. In this case, I have this bob here, this metal ball, and it's on a string. A good way of how kinetic energy and potential energy can get converted from one form to the other is with a pendulum. So as the pendulum swings back and forth, when it's up here at this height, it has all potential energy. And so as it swings and comes down and comes up to the other side, it's going to have the same amount of potential energy as it did over here. And so as it swings back and forth, that potential energy is maximum at the top of that height. Now, when the pendulum is all the way at the bottom, it's completely moving and there is no potential energy there. So when it's just sitting right there, it's not moving at all. There's no potential energy right there. The potential energy is only the energy of this ball here, this pendulum, can only do work whenever I move it up. Whenever I move it up and give it gravitational potential energy. And so at this point, it now has potential energy. When it's down here, it has zero potential energy. Now, the other type of energy was kinetic energy. So let's see how kinetic energy changes. So if we think about when it's way up here at the very top of the swing, it's not moving. Think about the split second that's at the maximum height. It's not moving at all. It has no kinetic energy. And so at that point, its maximum is at potential. It has a maximum potential energy and no kinetic energy. At the bottom of the swing, it has no potential energy because, as you can see, it's not moving. But it's all kinetic energy. So when it moves down as I drop it, all the potential energy up here gets converted to kinetic energy down here, and then it keeps moving, and then all that kinetic energy gets transferred back into potential energy. Now, if we lived in a perfect world and this was in a complete vacuum, as I swung this pendulum, it would swing forever and just constantly go back and forth. Now, this doesn't actually happen because there's friction, there's air resistance, there's transfer of energy through the string and things like that, where it will eventually slow down. But the point here is what I want you to get is that kinetic energy and potential energy gets transferred from one form to the other instantaneously. And it's not disappearing, it's not going away, it's not getting destroyed. It's just going from one form to the other automatically. Now, as I mentioned, there are many different forms of energy. And so the types of energy or forms of energy, I'm just going to kind of go through. We're going to talk very briefly about 6 different forms of energy. So the first one is mechanical energy. Mechanical energy is really like kinetic energy. It's an energy of motion. So when we're thinking about things are moving, like that bowling ball going down the alley, or even this pendulum going back and forth, that's all types of mechanical energy. It's kind of like the energy of motion. And it's usually the most common form of energy. When you're thinking about energy and things moving, that is mechanical energy. The second type of energy that is very common and that you're probably familiar with is electrical energy. Electrical energy is simply the energy that's found whenever a charge is moving. So it could be a positive charge or a negative charge. So whenever a charge is moving, there's electrical energy that's a form of energy, is electrical energy. Now, some materials can make that charge or is more apt for that charge to move. And so if charge can move very easily through a material, we call that a conductor. Electrical conductor is a material where electrical energy can easily move through the material. There's also thermal conductivity, so in that case it's heat moving through the material. Now the third type of energy is called thermal energy. Now thermal energy is a little bit nuanced in the sense that it's the energy of the molecules that make up something. So molecules are constantly moving around, and that motion of those molecules moving around is what we call thermal energy. And the way we measure thermal energy is through temperature. Temperature, as the temperature goes up, the motion of those molecules is going to become higher. So molecules move faster at higher temperature. Now, how do we know that molecules are actually moving around? Well, one way you can test this is by simply looking at a glass of water. You take a glass of water, let it sit there, and it's all still and everything, and put a drop of food coloring in it. Red food coloring, green food coloring, or whatever. You just put a drop in. Or if you have no food coloring, put some Kool-Aid, something that's colored, and put it in there. And then what you end up seeing, over time, that color gets dispersed. Now, how is that happening? That's happening because those molecules in the dye and the water are constantly in motion. And so they're just moving around, bumping into each other until it gets evenly spread throughout the whole glass of water. And so that is thermal motion. Thermal motion is that motion of those molecules or atoms, if it's a pure element, that is moving around. The other type of energy I want to talk about is radiant energy. Radiant energy we think of as heat. So whenever you get warmed by a fire, so that fire is producing radiant energy. That energy is coming at you and is basically increasing the thermal energy of the molecules on your hands or whatever, which you feel as heat. And so it's increasing the temperature. Now, radiant energy formally is an energy that gets it's a type of electromagnetic energy. So in the case of a fire, that radiant energy is that electromagnetic energy, which is more on the infrared, that is showing the transfer of heat that's happening, or the production of heat. Another type of radiant energy is the energy from the sun. The sun is providing energy to this planet. Also, a type of radiant energy that you are most likely use almost every day is a microwave. Whenever you heat something up in a microwave, that is radiant energy that's heating it up. Another type of or form of energy is nuclear energy. And nuclear energy is just energy that's within the nucleus of atom. And we make use of that in the terms of fission. And so later on, we may talk about nuclear energy and nuclear processes that happen. The final form of energy that I want to talk about is chemical energy. And chemical energy is the energy that is built into the molecules themselves. As the atoms are held together, they're being held together through electromagnetic forces, which we call bonds. And so there's energy built into those bonds. And so a molecule or a compound, just in its nature of the way those atoms are held together, the way those atoms are oriented and close to each other, there is energy built into that molecule. And that is what we call chemical energy. A good example of something that has lots of chemical energy is dynamite. Chemical energy can be used to just do different things, like blowing up buildings, which is moving things. That's the ability to do work. So those are all different forms of energy. We have mechanical energy, electrical energy, thermal energy, radiant energy, nuclear energy, and chemical energy. So 6 types or 6 forms of energy.